Welcome back. Today, we are jumping into one of the biggest debates in the data world. What's the best way to organize your data for analysis? It's a real clash of titans, elegant structure versus pure brute force speed. And you know what? In today's cloud-first world, the winner is not nearly as obvious as you might think. So here's how we're going to break this down. First, we'll talk about the core problem, the need for speed. Then we'll meet our two contenders, the classic star schema and the powerhouse flat table. We'll throw them into the ring to see how they perform in the cloud, help you figure out which one to bet on, and then land on a final verdict that, trust me, might just surprise you. All right, let's kick things off with the fundamental problem that both of these models are trying to solve. This is a question that really gets to the heart of what business intelligence and analytics are all about. I mean, when you're wrestling with terabytes or even petabytes of information, you can't just toss it into a spreadsheet and hope for the best. The real answer, the magic, is in how you structure that data inside a data warehouse. And this choice, this single decision, has huge consequences for everything. How much it costs to store your data, how fast your reports run, and ultimately, how much you can trust the numbers. So, in this corner, we've got the seasoned champion, the time-tested classic approach to data modeling, the star schema. I mean, this has been the gold standard for decades, and for a really, really good reason. The easiest way to think about it is like a perfectly organized professional kitchen. Your dimensions, that's stuff like your customer list, your product catalog, the calendar, they're all prepped separately, like your mise en place. The central fact table, well, that holds the action, the events, like sales. So when you need an analysis, the final dish, you just combine these perfectly prepped ingredients. In this picture shows you exactly why it's called a star. Right at the center, you've got your fact table, just the raw numbers and keys. Then radiating out from it, you have the dimension tables, which give all that data context. You know, who was the customer? What did they buy? When? The beauty of this is that it's designed to mirror a real business process, and you can reuse those dimensions over and over again, which makes it super sustainable and incredibly scalable. And hey, you don't have to take my word for it. This quote from a user on Reddit just nails it. The star schema isn't just about organizing data randomly. It's about modeling the business itself. It provides that consistent, reliable context everyone needs, and it keeps the data clean, which is absolutely critical if you want reports you can actually trust. Okay, and in the other corner, we have the powerful, no-nonsense challenger, the flat table. You'll often hear people call it OBT for one big table. So if the star schema is a restaurant kitchen, the flat table is like a meal prep kit. Every single thing you could possibly need for one specific analysis, the customer's name, the product's color, the transaction date, the price, it's all pre-packaged and waiting for you in one single wide box. The best part? No assembly required. And this right here is its superpower. Another Redditor points out that some of the big modern data engines, especially massively parallel processing systems like Spark, they hate joins. Joins are slow, they take a ton of resources, but what these systems are absolutely amazing at is scanning huge tables in parallel. A flat table plays right into that strength. You can chop it up, give a piece to 100 different computers, and get your answer back at lightning speed. Okay, so we've got a classic matchup, right? The flexible, super organized star schema versus the blazing fast, specialized flat table. For a long time, they were pretty clear winners. But the rise of modern cloud data warehouses, that hasn't just changed the rules of the game. It's why this debate is hotter than ever before. The thing is, with the huge variety of architectures we have in the cloud now, there's just no one-size-fits-all answer anymore. The best choice depends entirely on the specific database technology you're using. What's a brilliant move for one system could be a total disaster for another. And that's the key shift in thinking we all need to make. A performance analysis published in the journal MDPI found something fascinating. They tested both schemas on different kinds of cloud databases. The more traditional columnar databases, like Amazon Redshift, which are built to be amazing at joins, they still perform best with a star schema. But the newer hybrid systems, the ones called NewSQL or HTAP, actually performed way better with a totally flat table. So get this, that same research found that flattening out your data can increase the total amount of data you're storing by 4 to 5 times because you're just repeating information over and over. Now, that sounds awful, right? But here's the crazy part. For some of these modern systems with amazing compression and parallel power, that massive storage increase is a trade-off they are more than willing to make to get query results back way, way faster. So, knowing all this, how in the world do you actually choose? Well, it all comes down to matching your data model to your tech and to the specific problem you're trying to solve. Okay, so let's boil it all down. This is your cheat sheet. The STAR schema is still your champion for flexibility, data integrity, and scalability, especially on traditional systems like Redshift, or if you're using a BI tool like Power BI that's built for it. But you should absolutely consider a flat table when you need pure, unadulterated speed, especially in a Spark or NewSQL environment where you're just scanning tons of data and you're willing to pay more for storage to get that performance boost.
So, after all of that, what's the ultimate conclusion? Who's the undisputed winner in this great data debate? Star schema versus flat table.
The reality is, the battle's over. There isn't a single winner. The goal for a data professional today isn't to pick one champion and use it for everything. The real skill is knowing the trade-offs, intelligently choosing the right structure for the right technology for the right problem. Sometimes it's a star, sometimes it's a flat table, and a lot of the time it's probably a mix of both. And that leaves us with one final kind of mind-bending thought. We've spent all this time debating the best way for us, as humans, to structure data for machines. But what happens when those machines get exponentially more powerful, when they're driven by AI? Is it possible this entire debate just becomes irrelevant? We might be heading toward a future where we just give the machine the data and it figures out the best structure all on its own. Something to think about. Thanks for tuning in.